Hello everyone. Welcome to this video on Mergesort, the part 2, the Python code for Mergesort. In part 1, we saw what is Mergesort and how it works with the help of an example. We saw in detail how recursion is actually performed in a Mergesort. In this part, we will write a Python code for the example that we already saw in the part 1. The first step in Mergesort is to divide the entire array at the middle into two sublists till we get a small sublist which is of size 1 and which we call as the base case. To start with, I have to find the middle value of the index. The indices start from 0 to 7, and so the mid value, mid is equal to floor of low plus high by 2, has to be implemented in Python. So we import math and write math.floor with the formula. We find the mid value using the formula math.floor and we get the answer as 3. So the mid value is now 3 because low is 0 and high is at 7. Let us divide the array into subarrays. Since we are using Python, we are not going to use arrays, but rather we're going to use lists here. So I need to repeat it. That is, I need to recursively split it into sublists till there's only one element in the sublist. So I use if low less than high. In other words, if low and high are pointing to the same element, it means there's only one element. But if low is less than high, then it means that there is more than one element. So recursively, we divide till we find a sublist which has only one element, which we call as the base case. Low is at 0, high is at 7, low is less than high, and the mid is at 3. We have already divided it, and now we do a splitting. In other words, we call Mergesort recursively. Now the new value of low is still low, but the new value of high is mid, which is 3. This creates the sublist from 4, 1, 2, and 5. Here, low is at 0 and the high is at 3. When I find the mid value is now 1. That is 0 plus 3 by 2. Now that I have again split it at the middle, I create the next sublist. Recursively, only the left sublist is being created. Now this creates a sublist with the values 4 and 1. Now the low is at 0 and the high is at 1 because the mid value in the previous parent was at 1. Again, I find the mid value. The mid value is for 0 plus 1 by 2, which is 0. So again, divide it like this. This results in a single sublist where the low value and the high value are at 0. At this juncture, low is equal to high and the recursion stops. Let's see what are the functions that are called. Mergesort on 0, 7 finds the mid value and calls Mergesort on 0, 3, which again finds the mid value and calls Mergesort on 0, 1. Please note it's the same line that is being repeated over and over again in the recursion with different values of low and mid. In other words, with different values of mid alone. And then finally, we have Mergesort on 0, 0. This is when we stop the recursion. Mergesort A of 0, 7 calls Mergesort on 0, 3, which calls Mergesort on 0, 1, which calls Mergesort with the values 0 and 0. Now that we are at the base case, we have to compute a subproblem. In other words, I have to find the sorted sublist. The sorted sublist of a single element is itself, so we do nothing when we come to the base case. Now that we have come to the base case, we now look at the right of the sublist. The innermost sublist is 4, 1, and so the right of the sublist is the element 1. Here, the value of low and high are 1. Merge sort on 0, 1 calls merge sort on 0, 0, falls into the base case, returns to the parent, and at the parent, it calls mid plus 1, high, which is nothing but 0 plus 1, which is 1, 1. So let's see again how it actually calls the functions one by one. So after a of 0, 1, it calls merge sort on a 0, 0. This gets returned, and again this calls a on 1, 1, which is again returned to a of 0, 1. Now we are again at a base case, and the subproblem is of size 1. It is already in the sorted order, so we need to do nothing. After I return to the parent now is merge sort on the value of low is 0, value of high is 1, and the value of mid is 0. Merge is a function which takes two sublists, one from low to mid and another from mid plus 1 to high. One we call as the left sublist and the other we call as the right sublist. And the left sublist and the right sublist that goes into merge are already sorted. And the function of merge is to sort these two sublists and to make a bigger list of two elements. So now I take a sublist of one element on the left, a sublist of one element on the right, and I make a list of two elements which are already sorted. Initially, in merge, we have two pointers. One we call a subarray 1 and one I call a subarray 2. Subarray 1 is a pointer that moves across the first sublist, and subarray 2 is a pointer that moves across the second sublist. In other words, subarray 1 is a variable which holds the index of all the values in subarray 1, and subarray 2 is pointing to the second or the right sublist and has the indices of the right sublist. Merge is also called as the Cartquark phase. So in subarray 1, it stores the value of low, which is 0. In subarray 2, it stores the first element in the right sublist, which is mid plus 1, which is 1. And in merge sort, we have a temporary array. And this temporary array is used to sort and write the sorted elements in the intermediate stages. And temporary array, the first position that I'm trying to write the value is at the position 0. So now in the temporary array, 4 is at index 0 and 1 is at index 1. The temporary array will now sort and write the values in indices 0 and 1. We check the value in subarray 1, which is 4, with the value in subarray 2, which is 1. 4 is greater than 1. And so we write into the subarray the value 1. And then we move the value in subarray 2. Now the value goes to 2. The value in the temporary array moves from 0 to 1. We see that subarray 2 has moved from 1 to 2, and the entire sublist we have completed processing, whereas there is still one element left in subarray 1, which is 4. That we check with the help of if subarray 1 is greater than mid. 1, is it greater than 1? No. So it comes to the else part. So for the range from 0 to 1, that is for the value I is equal to 0, write into the temporary array the value 4. Now the temporary array has the sorted list 1, 4, which is after sorting the left sublist and the right sublist. Now we have to rewrite into the original array what is in the temporary array. So in A of 0, we write temp array of 0. So 1 is written first and then 4 is written. Now let's see how to conquer the sublist which is on the right hand side, which is 3, 6, a sublist of size 2, and 7, 8, a sublist of size 2. Currently, I have 2 sublists, one on the left, one on the right. Remember, when we give to merge, the input is such that the left sublist and the right sublist are already sorted, and that is why this merge algorithm works. Subarray 1 starts from the first index of the left sublist, so it has the value 4. Subarray 2 starts from the first value in the right sublist, so it takes the value 6. And we are trying to conquer the sublist on the right hand side in the indices 4 to 7. So temporary array is now pointing to the location 4. And currently, the value of low is 4, the value of mid is 5, and the value of high is 7. 3, 7 have to be compared. Now when 3 and 7 are compared, 3 is smaller, and so we write 3. Then subarray 1, the pointer is moved as shown in the if statement. That is subarray 1 is equal to subarray 1 plus 1. Then we check 6 and 7. 6 is smaller, so it is written into the temporary array. And the value of subarray 1 now goes to 5. In other words, we have completed processing one entire sublist which is on the left side. But still 2 elements are remaining on the right hand side. So for that, we have to check which sublist still has elements left. So we check if subarray 1 is greater than mid. Subarray 1 is greater than mid. First we write 7 into the temporary array, and then we write 8 into the temporary array. As shown in the figure, the temporary array starts at the location 4. At this procedure, we have considered only the elements on the right hand side from 4 to 7, and we have completed sorting the elements on the right hand side, and we have written the sorted list into the temporary array. We have seen how sublists of size 1 are conquered. Then we saw an example of how sublists of size 2 are conquered. Sublists of size 2 when conquered result list of size 4. We started with an array with 8 elements. So at a position, the left sublist of 4 elements and the right sublist of 4 elements are already sorted. We compare the elements on the left sublist and the elements on the right sublist. Subarray 1 moves from 0 to 3. Subarray 2 moves from 4 to 7. Initially, we have the value of subarray 1 to be 0 and the value in subarray 2 to be 4. We compare 1 and 3. The smaller value is 1. We write it into the temporary array. And now the temporary array ranges from 0 to 7. 2 and 3 are compared. The smaller element is 2. 2 is written into the temporary array and the pointer is moved to represent the element 4. In other words, the value in subarray 1 is 2, but subarray 2 still remains at the position 4. Now 4 and 3 are checked. 3 is smaller. Now that 3 is written, subarray 2 moves from subarray 2 is equal to subarray 2 plus 1, which is now the value 5. At the position 5, we have 6. The smaller value is 4, and so 4 is written into the temporary array. And the value in subarray 1 changes from 2 to 3. We check 5 and 6. 5 is a smaller value than 6. So 5 is written into the temporary array. And the value in subarray 1 is moved Now we have completed all the elements in the left sublist. So we now move to the second part of the algorithm, in which one part of the sublist has already been conquered and the second part of the sublist still has elements. All we do is write the elements in the second sublist to the temporary array. So 6 is written onto the temporary array. This is shown in the for statement for I in range of subarray 2, I plus 1. So 6 is written, 7 is written, and then 8 is also written into the subarray. Finally, the temporary array is already sorted and the values have to be written into the main array. So the values 1, 2, 3, 4, 5, 6, 7, and 8 are written into the main array as shown in the code. To conclude, we have seen how the Python code can be written for the merge sort algorithm. In the description below, we have given the link to the GitHub repository and in which you can find the entire code as a Jupyter notebook.